Alright, so we're going to be talking about how to take integrals of some difficult fractions, some difficult rational functions. But what I want to start with is a simpler idea, which is if I wanted to add these two fractions, what would I need to do? Well, we know that when you add fractions, you need to become so if I multiply this by x plus 1 over x plus 1, and multiply this one by x plus 3 over x plus 3, now we have a common denominator. So we could simplify that. We get 2x plus 2 plus 3x plus 3, 3x plus 9 rather. Knew I was doing something wrong. So 3x plus 9 all over x plus 1, x plus 3, and last step would just be to simplify. So we get 5x plus 11 all over x plus 1 times x plus 3. So what we did is we took two separate fractions and consolidated them, condensed it into one fraction. So what we're going to do in this class is work the other direction. So I want to take this fraction and expand it into two fractions. Why? Well, that'll come. Let me just do a preview, because I'm going to want to take this integral. And this integral is very difficult, but the integral of simpler fractions would be nice. So for now, we're not taking an integral. We just want to write this as, we're going to write this as two fractions. So the first step is to factor the bottom. So when we factor the bottom, we get x minus x plus 2, x minus 1. And then we're going to split the factors. So we could write this as something over x plus 2 plus something else unknown over x minus 1. And now our task is to find a and b. Well, we're going to find a and b by adding this together. So we know that we have a x minus 1 over x minus 1, x plus 2, plus b x plus 2 over x minus 1, x plus 2. And this needs to equal 3x over x plus 2, x minus 1. So what we can do is further simple. So if we look at the numerator, 3x must equal ax minus a plus dx plus 2d. And it might be simpler on the left-hand side to think of this as 3x plus 0. This lets us see that 3x must be ax plus bx, looking at the x's, and 0 must equal negative a plus 2b. Therefore, a equals 2b. And using substitution, we can get 2b for a. We get 3x equals 2bx plus bx, or 3x equals 3bx. Therefore, b equals 1, and a equals 2. So now we took that original fraction, 3x over x plus 2, x minus 1, and we were now able to write it as two simpler fractions, 2 over x plus 2 plus 1 over x minus 1. So this is a technique of writing a fraction, condensed fraction, as partial fractions. is going to greatly enable us to um, take integrals of otherwise very difficult rational functions. So now let's actually do that. We want to take the integral of this function that we were just looking at. Well, we've already done the work, so we know that this equals the integral of 2 over x plus 2 plus 1 over x minus 1 dx. So we can split that integral. We can integrate 2 over x plus 2 dx plus 1 over x minus 1 dx. And we know that we're going to be looking at some natural logs. So this equals 2 times the ln of x minus 2 plus ln of x minus 1. And since it's an indefinite integral, we are going to have plus c. Now what we want to do is consolidate this. So this is going to require us to remember some of our log rules. We can put those 2 up top. So we get ln of x minus 2 squared plus ln of x minus 1 plus c. And since we're adding 2 natural logs, this equals ln of x minus 2 squared times x minus 1 all plus 2. So this, had we not split it up, we wouldn't know how to integrate that. But now using these partial fractions, we're able to take a difficult fraction, split it into 2 partial fractions, which are both integratable. All right, let's do a slightly harder one. Very manageable though. So first thing, factor the bottoms. Well, before we take the integral, rather, let's split this up into partial fractions. So factoring the bottom, x squared minus x plus 4, leaving the numerator the same, we get x times x minus 2, x minus 1. And this is going to equal a over x plus b over x minus 1 plus c over x minus 2. Okay, so if we were then to take this and re-expand it, this equals a times x minus 1, x minus 2 plus b x minus 2 plus c x minus 1, and that's going to have to equal the numerator on the top, x squared minus x plus 4. And just to be totally clear, all over the common denominator, please common denominator, which is x minus 2, x minus 1, x minus 2, x minus 1. But we're just going to be looking at the numerators now to figure out what are a, b, and c. Okay, so this is a nice technique here. Let's say when x equals 0, when x equals 0, this will be 0, because anything times 0 will be 0. So when x equals 0, our left-hand side of the equation, here's our left-hand side. When x is 0, our left-hand side is just 4, and our right-hand side is going to be a times negative 1, putting 0 in for x, times negative 2, putting 0 in for x. So we have 4 equals 2a, a equals 2. So I'm going to choose, I chose a value that made that factor 0. Now let's choose a value that makes that factor 0. So when x equals 2, the left-hand side of my equation, would be 4 minus 2 plus 4, or 6. And when x equals 2, this will be 0, this will be 0, but this won't be 0. So we're going to get c times 2 times 1, putting 2 in for x there. So this gets us that c equals 3. And now let's say x equals 1. When x equals 1, we're going to plug 1 into the left side. We're going to get 4. Then we'll plug 1 into the right-hand side. This will be 0. This will be 0. But this won't be 0. So plugging 1 into there, we get b times 1 times negative 1, or b equals negative 4. So now we're able to write my fraction as a partial fraction, and we can say this is the integral, because remember we're trying to find the integral of a over x. Well, a is 2, so 2 over x, plus b over x minus 1, well, b is negative 4, so plus negative 4 over x minus 1, plus c over x minus 2, where c is 3, so plus 3 over x minus 2. And we're going to do this over on the next page. So splitting up those integrals, we could write that as the integral of 2 over x dx plus the integral of 3 over x minus 2 dx plus the minus the integral of 4 over x minus 1 dx. And just to go back to that last page so that you can see that. I've just moved this one over to the right-hand side so that it's positive, positive, negative, and then I just split up each of these into separate integrals. So now we just need to take each of these integrals, and again, we're using ln, so we're going to get 2 times ln of x plus 3 times the ln of x minus 2 minus 4 times the ln of x minus 1 plus c. Once again, we're going to use that power rule. And we're adding these fractions, or adding this logs and subtracting that log. So we're going to be multiplying and dividing. So we get the ln of x squared times x minus 2 cubed all over x minus 1 to the 4th plus c. That's it for now. Kind of a lot. But just to go back and think about what we just did, the main idea is we're taking fractions, or we're taking integrals, like this, going up to the top of this page. We're taking a very difficult integral, and we're splitting it up into simpler partial fractions, which we can integrate with much greater ease.